There seems to be a lot of confusion about how to interpret the graph after doing a simulation. So I want to go back and revisit problem number 27, which we did for homework earlier. So problem number 27 was based on about colorblind men. It said about 7% of men in the United States have some form of red-green color blindness. And that's problem 25. Then problem 27 refers back to exercise 25 and says, suppose we randomly select one U.S. adult male at a time until we find one who is red-green colorblind. Should we be surprised if it takes 20 or more men? Okay, so if we look at the key on this, the process here, the simulation, what I want to find out is what is the probability that I will need to randomly select 20 or more men in order to find one colorblind man, because I want to know how unusual that is. So I assigned 7 out of 100 numbers, 7 out of 100 two-digit numbers to represent colorblind, and I use 00 to 06 for colorblind and 07 to 99 for not colorblind. Some of you may have used 01 to 07 and 08 to 99 plus 00 for not colorblind. Then I went to my table and counted two-digit numbers until I found one that was between 00 and 06. And the first time it took 27 numbers till I got the first one that was represented colorblind. The second time it took 35, the third time 3, and so forth. So lots of variety. So I did, these are the first 10 of 20 tries that I did. So what I did was I looked at two different homework papers, each of which had assigned numbers a little bit differently. So I took 15 trials from each of the homework papers and got a total of 30 trials and made a graph of them. So that's what this is right here. Each one of these represents how many numbers I had to pick until I got the first number that represented a colorblind man. So you can see that there's quite a lot of variety, but a whole lot of small values and a few very large values. Now, I don't necessarily vouch for these trials being super accurate, because I just grabbed a couple of homework papers and took the numbers off of them without checking them thoroughly. I did have some students comment that there seemed to be maybe more low numbers than there should have been, but I think the results actually aren't too far off what they should be. My guess is this column represents 1 or 2 men needed to get the first colorblind man, and then larger numbers after that. I think I would have expected a few more in this area rather than this area, but this is what I got. Anyway, we can still interpret it whether or not the simulation was done perfectly right by the two students I picked. I think this will still illustrate what I want to illustrate. So how do you answer the question using the statistics and the graphs? So the first question is, how many men would you have to select? Well, obviously, there's a great deal of variability here. But you can comment on that variability by describing the graph and by looking at the statistics. Okay, so here's how I answered the question. Based on my simulation, it took an average of about 12 men, because I got that from the data here, and the statistics, to find the first colorblind man. The median value was 8, which shows that 50% of the time I only needed 8 or fewer men to get the first colorblind man. However, there was a great deal of variability in the upper 50%, as seen in the large standard deviation of 12.976 men. So right there, large standard deviation. I could have also commented on the range of 55, that there was an outlier at 55, and so forth. And the fact that the graph was skewed to the right. But basically, I needed to say, the first question was just answering about how many minutes it took. So it makes sense to talk about both the middle, the center, and the amount of variability. Okay, that's what you need to talk about here. Now the second question was, would you be surprised if you had to select 20? Now, when we think about 20, you also need to think about 20 or more, because if you had to select more than 20, you would maybe even be more surprised. So we want to look at 20 or more. So in this question, you really need to look at the graph. It helps to know that n is 30. That means there's 30 trials altogether, so you don't have to count the dots. In those 30 trials, there were 6 trials where it took more than 20 men to get the first colorblind man. 6 out of 30 is the same as 1 out of 5. 1/5 is 20%. 20% is not all that unusual. For something that happens 20% of the time, happens 1 out of 5 times, I don't consider that unusual. I would consider something unusual if it happened maybe 5% of the time, not 20% of the time. Okay? So here's how I answered the second question. I would not be surprised if I needed 20 men to find the first colorblind man. In 6 out of the 30 trials, 20%, it took more than 20 men to find the first colorblind man, with one trial taking 55 men. So needing 20 men or more would not be typical, but not all that unusual either. So this is the kind of thing we are looking at when we ask this question, surprising, or how unusual, or what is the probability. Look at how often it happened on the graph. Okay, count the dots. How many total trials did you have? How many of them were what you were looking for? If what you were looking for is not unusual, it happened frequently enough or with a high enough probability that I would not consider it extremely unusual, then I would say no, I'm not surprised. Okay, so that's what we're looking at on here. I hope this clarifies how to answer a question like this.